for not everyone, of course, but for a lot of people, the minute you put trig and calculus together, a monster gets created. We are going to have to be, well, essentially the heading tells us we're going to integrate things with trig in it. And we're going to integrate combinations. So we're going to integrate things that have sines and cosines in them. And we're going to integrate things that only have sines or only have cosines in them. So, and we're going to do things with secants and tans in them. And we're going to do things with only secants or tans in them. And then we're just going to do, because I can't think of a good term, mixed ones. So you can imagine there are, there the latecomers come. There are, in fact, many different combinations of integrals that involve trig. And it would be nice if I could say there was a single method that would do all of them, but there's not. You're going to have to basically take each question as it comes and figure out a strategy or a technique for doing them. And that's a big problem. It's a lot easier when you know that every single question is a U-sub, or that every single question is an integration by parts, or whatever it is that's going on. It's a lot easier to do a question when at least you know the starting point. But in these questions, there is a lot of variation in what you could end up doing. So let's look at questions involving sines and cosines together. Suppose I wanted to do two sine squared x cos cubed x dx. There's essentially going to be three main strategies. The one I'm about to tell you won't cover every possibility, but it will cover a large majority of them. There are going to be three main strategies. The first strategy is going to be U-subs. Think of a U-sub that would solve this question. The second strategy, pretty rare, but occasionally happens, think integration by parts. But don't think integration by parts as your first go-to guy. Always think of U-subs. And the last one is, can I use a trig identity to change the way the thing looks? That's more likely to happen down here. So, looking at this one here, what strategy do you think might be the good direction to go to solve this question? How could I tackle this?
Would we start by using the reduction formula on cosine cubed of x?
What an interesting thought. Let me think about that for a minute. I don't think that would be successful in this case. Now, if it was just a cosine on its own, yes. But the sine squared, I think, screws up with it. Plus, you have to incorporate it. So you'd have to do probably something along the lines of a combination of that and something else. So I don't want to throw it out totally. But even if it did work, it probably wouldn't be the most efficient way. So think of something else.
Is that a trig identity?
Well, there are lots of trig identities I could use. I guess I could do some replace sine squared with 1 minus cos squared, or I could replace it by a half. brackets 1 minus sine of 2x, none of them would actually do any good. Nobody's mentioned the technique that we should use. Maybe it's the first one and you just didn't see it. It's going to be a long day today.
Is it using a user of cosine?
It is. Okay, we got it. It's a U-sub. Now, there are two choices in these U-subs. Sine x on its own or cosine x on its own, right? Don't go anywhere scary. That's the place you go, right? Sine x on its own or cosine x on its own. One of them will do good and one of them will do bad. One will work and one won't. Now, before you say which one it is, because you have a 50-50 chance of guessing, try and think through what would happen with the U-sub you're about to say. Will it come out good or will you have a problem? So who's the U-sub going to be?
Cosine.
Okay, if I pick the cosine, that would turn into u cubed. That's good. If I picked a cosine, wouldn't I kill one of these sines? But wouldn't there only be a sine left? And that would be the end of the line. Because that would turn in, well, I don't know what it would turn into, but whatever it turned into wouldn't be any good. So, since cosine can't work, we'll do sine. Now, if you differentiate with respect to x, you get a cosine. You do the crossover, you get a cosine x dx. If you divide everybody by cosine, you get dx. If you're wondering why I'm doing so much pausing here, the last thing I want to do is tell you how to do each one. Because if I tell you how to do each particular one, all you have learned is how to do that question. You haven't learned anything else except, okay, I now know how to do a sine squared cos cubed. You have to have a bigger picture. You have to have a mindset of how do you do all the other combinations in the universe, like sine cubed, cosine to the 10th, you know? How do you do those guys? So let's see what happens next. Well, I have 2 sine squared x times u cubed times, excuse me, let's try that again. It's going to be 2 u cubed cosine x times 1 over cosine x du, and that's now going to become 2u squared cosine squared x du. Now, it's not uncommon for these questions that involve sines, various powers of sines and cosines. It's not uncommon for you to get a guy that's left over. As long as the guy that's left over is a square, everything's good. Now, if that guy that's left over is cosine x on its own, or cosine cubed, or cosine 5, right? Odd powers, bad news, pick the other guy. Somehow or other, I have got to change cos squared x into u's. And I'm going to use a trig identity to do that.
Is that going to be from sine squared plus cosine squared equals 1?
You nailed it. And if we look at sine squared plus cos squared x is 1, if you rearrange that, what does cos squared x equal?
1 minus sine squared.
And 1 minus sine squared become 1 minus u squared, and we've done what we said we needed to do. We have now got the integral of 2u squared instead of cos squared 1 minus u squared Do you? Expect to do a lot of thinking in these questions. But also, as we go on, I hope you start getting more comfortable with the processes that you're going to use. Okay, what do you think I should do next? I want to integrate this, which is doable, but I have to do something before I can get it to the doable stage.
Distribute the 2u squared.
Does that seem reasonable? I hope you agree. Can't we now do the power rule? So I'll add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Are we finished? Correct. What do we need to do now?
We need to substitute sine of x back into u.
Right. So get it back to the x's. So this question involved the u sub. So here's your first kind of rule. If you see different powers of sines and cosines, right? So one of them's cubed and the other's 4, one of them's squared and the other's 5, right? As long as they're different powers, go for a u sub, it will work, right? So if the sines and cosines are different powers and there's at least one odd, go for a u sub. And by the way, that was question 1 or similar to question 1 in the homework. Let's go for this one then. Sine cubed y, cosine 8y, dy. So I want you to think of u sub again. That's your go-to guy. U sub's very common in these questions. Problem is sometimes you have a choice. Well, actually all the time you have a choice, but one of those choices is good and the other choice is bad, typically. Sine or cosine, who are you going for?
It's cosine, because that's going to leave us with sine squared y.
Did you catch that? What you said? It's picking cosine because eventually it's going to leave a sine squared y. If I picked a sine, wouldn't I end up with a cosine left over eventually? I'd had some like 7 of them, but one of them would be left over and we don't like leftovers. So you differentiate with respect to y and you get negative sine y. You do a crossover. And then you divide to isolate dy. So this fella becomes sine cubed y, u to the 8, 1 over sine y du. It now becomes sine squared y, u to the 8, oh, and I forgot my negative. There we go. Du. Okay. You see this little identity down here? He's going to be your friend. Can you see that we can do something with sine squared y? Can't we rewrite it in a similar way to this, but rewrite it as 1 minus cos squared? And 1 minus cos squared is 1 take away u squared, u to the 8. Is this question beginning to have a flow to it? Kind of a way that they work? Now, what do you think I should do next? Because this is doable, but I have to do something first. What will I do here?
Will you distribute the u to the 8?
You will. And hopefully I'll distribute it correctly. And then I'll do the power roll. And then I'll return back to the X's, or in this case, the Y's. Right, so right now we're just working on combinations of powers of sines and cosines, where they're different. In this case, they're both one's odd and one's even. Okay, so that's the second situation, second example of this situation done. This question is a U sub. Who's our U sub going to be? Think,
Sine to the power of 17.
oh, I like the sine until you said the 17 part.
Oh, what about sine to the power of 14?
No, how about no powers at all?
Oh,
Sine on its own.
yeah. Sorry, it's a good idea.
Remember, U subs almost, I'm sure there's always an exception to every rule in the world, but you're probably not going to see that exception this time. Sines and cosine powers are always, if they're going to be a U sub, it's always going to be a single value, right? A sine on its own or a cosine. I do like your sine. I think that was the right choice. Why were you picking the sine rather than, the alternate was to pick the cosine? Why pick the sine in this question? I mean, maybe you just picked it because it's a good idea, but is there
Because
something?
then you get u to the power of 17, which is a lot easier to work with than,
Yeah, nailed it. Do you know I could have done the cosine, and theoretically the cosine of x as a U sub would have worked. Would you, if you try to do it, trust me, the algebra is horrendously ugly. Not that this is going to be easy. It's going to be a lot easier than it would be with the other choice. So do a crossover, do the crossover, and then isolate by dividing by cosine x. So it's going to be u to the power of 17. That's what made that U sub so good. Multiplied by cosine cubed x times 1 over cosine x du. And that leaves me with u to the 17 cos squared x du. Are we getting comfortable with a cos squared or a sine squared being left over? Because if you get really lucky, sometimes they're not, but pretty much you expect to see something like that, don't you? At least on the ones that we've done. Let's see if I can skip a line. What will cos squared turn into if you use u? So basically take these lines and combine them. What will cos squared get you?
1 minus sine squared.
And that will turn into 1 minus u squared.
Mhm.
So as you do them, you might skip a line of working essentially. Are you comfortable with that? Have you noticed that at least so far, don't the questions tend to finish with some kind of you distribute? Can I just dot that one? Won't that be the power roll and then switch it back? Right. So I think that one ends pretty much the way they typically do. And this one's a version of question 3. So let's see if I can find one I want to see. No, don't want to say that one. Okay, I'll make one up. Just doing an uglier version of this one. And all I've done is upped the power to the 5th. I'm still going to do the same u sub. So this is going to become u to the 17, that fella, 1 over cosine x du. And that is going to become that fella. And the reason I wanted to do this is you're going to probably find sine squareds left over and cos squared left over. A little bit less likely, you might end up with a sine to the 4 left over, or as in this case, a cosine to the 4 left over. Right. We are doing a u sub where u is sine x. That means we've got to figure out how to write cos to the 4th x in terms of sine x, so we can convert it to u's. Now, I already know, because I've done it a couple of times, that cos squared is 1 minus sine squared. Agreed? So that makes cos squared x 1 minus u squared. Right? But what, in terms of u, does cosine to the 4th power of x get you? Cos squared x gets me this, but what does cosine to the 4th power get me?
1 minus u squared squared.
Wouldn't it be 2 minus?
2? No, yeah, you're squaring, you're multiplying something by itself, so this would be the right one. So if you want to think of cos squared x squared, yeah. Now, distribute using FOIL. And then distribute to u to the 7. Yes.
The original question's sine to the power of 17, right?
Oh, thank you. Looks good. Da. So, as long as after the u sub, the trig that's in x's, so the sine or the cosine it's probably going to be left over. As long as that's even, you're good. Now, if it's sine squared, you'll end up with a 1 minus u squared. If it's a cos squared, you'll end up with 1 minus u. If it's a cos 4 or a sine 4, or God forbid, a cos to the 6 and a sine to the 6th power, won't you still be able to convert it into u's? And the whole goal is in a u sub is to take an integral that has x's in it and convert it to a simpler one that you can do that only uses u's. And at this point here, I would be using a u sub. So now that you've got comfortable, if that's the right word, I guess, with sines and cosines mixed up, let's do only sines. We're going to look at single powers of sines or cosines with odd powers. So what I'm about to show you this technique will work for sine cubes, sine 5s, sine 7s, cosine cubes, cosine 5s, cosine 7s, right? So it's a very niche market. So let me show you how we're going to do this one. which seems a bit strange. Pull out, since it's odd, you can do that. Pull out a single x, whatever's left gets left behind. Sine squared x can be rewritten as cos squared x, the x. So you will convert your original single sine power into a single sine x with whatever is left in terms of cosine. So far, so good. What technique do you think I'm now going to use to integrate this?
U sub sin x.
I like the U sub, but not the choice. So not sin x.
Oh, if you choose cosine x, wouldn't you get the sin x to cancel out?
Yes. So differentiate with respect to x is negative cosine x. Do the crossover. And then divide everybody by cosine x. You know, I wish I'd printed like 50 of these on little sticky tapes. Because if you notice that my U subs are only two different guys and it's the same blinking combination every time and I have to write it. If I had it, I'd just go sticky tape down. There we go. For the sine, sticky tape down, there's the cosine. So let's see what we have. We have sine x, a 1 take away u squared, a God, I'm getting old. Nobody noticed that deliberate mistake, did you, guys? When you differentiate a cosine, you get a sine. Yeah, now I'm good. Because it's negative 1 for sine. There you go. And the sines cancel. And I'm looking at this guy. And I'll distribute the negative to get that guy. Would you agree at this point it's just a power rule and we're finished? You know, add 1 to the power, divide by the new power, and then convert to x's. So that's how you do a sine cubed on its own. Let's try an odd power again, but a cosine. If you've got a sine that's an odd power on its own, or a cosine that's an odd power, as it is here, on its own, then you will pull out, in this case, a cosine. And you will leave behind the rest. You will think of this guy in terms of cos squareds. And cos squared will become sine squared. Did you see the algebra that I've been using to convert this cosine into a single cosine with some sine stuff? What U sub will we use now? What would be the correct U sub to use in this integral?
Sine of x.
And after a whole load of work, which I'm not going to do, you will end up with 1 minus u squared squared. You'll add the dots in there, and then you can finish it. Are we good? So let's do evens. Still sines and cosines, but only on their own. So this would be an example of question 6. And let's do 9. cos squared theta d theta. This is even a more niche market than the one we've done. This technique you can use for sine cubed, sine 5, sine to the 11th, and it'll work, and it won't be too difficult. You can do it with cos cubes, cosine 5s, cosine to the 13th, and it'll be pretty much the same process. This technique will work for even powers on its own, and it's going to be different, essentially completely different than the technique that we've been using. And for practical purposes, you probably aren't going to be able to use it much beyond the fourth power. So you'll be able to use it for sine squared on its own, cos squared on its own, sine to the fourth or cosine to the fourth. Could you use it for cosine 20th? Yes, but you would probably be an old man or woman by the time you finished it, so you're never going to do it, right? But we could do it for small ones. And we are going to use a trig identity, but not the one you're thinking. You're probably thinking 1 minus sine squared, which is definitely sensible, right? We're not going to go anywhere near there. The trig identity that we're going to use is this one. That cos squared can be rewritten as a half 1 plus the cosine of 2 theta. And its corresponding one for sines is a half 1 minus cosine of 2 theta. Has anybody seen those two guys before? And if you haven't, you may want to write it down somewhere because you're going to be using them for the next 5 or 10 minutes. Okay, so cos squared is going to be replaced by this fellow. And that's 9 halves times 1. Let's do it this way. Actually, not much of a line. Let's pull out the 9 halves, which is kind of where my brain was thinking. So hopefully you can go from that line to that line. You don't need that one, right? Actually, we are ready to integrate this. I don't need any, well, I don't see it as a u sub, some of you might. Can we just use the linear shortcut method? So if you integrate 1 with respect to theta, you get 1 theta. If you integrate a cosine, don't you get the sine of 2 theta? But because it is a 2 theta, what do I also get here, where my finger is? What does a 2 theta get you when you use the shortcut method?
A half.
I guess it's a half. Now, if you don't like the shortcut method, why don't you just do a little baby u sub of 2 theta? I'm not quite sure why I stuck my c there because it doesn't really belong there. There, would you agree that that's nothing at all to do with u subs, really? Wasn't it all to do with integration using a trig identity? Now, you don't get many choices of this. You only get 2s and 4s. So that means there's only really 4 questions in the universe as far as you're concerned. And there's one of them. So for the other one that's left, let's do it with the 4th power. So if you can do the square power with sine and the 4th power with sine and then the 4th power with cosine, you've done the only combinations of these and even guys that you need to worry about. So let's figure out what to do. Sine squared is going to be this guy. So this fella, and I'm taking it nice and slow, is that. Would you agree? That sine to the 4 is a sine squared. Good grief, what's the time? Oh good, it's my watch that's out. Now, sine squared can be written as 1/2 1 minus the cosine of 2 theta squared. Now, if you want to square this fella, you're going to get a quarter, and then you're going to get a 1 minus cosine of 2 theta. I'm going to bring that 3/4 out, and we're going to be left with 1 minus the cosine of 2 theta squared. Okay, where are we off to next? What should I do next?
Would it be dealing with the squared foiling?
Yeah. And everything was going really well until I write down the last term. That's good. I can do a shortcut on that. That's good. Yuck. Cos squared 2 theta is biting our bum. Because cos squared 2 theta can't be integrated. You can't do a power rule on it. You couldn't do anything like that. So I'm going to have to show you another trig identity. It's really this identity, but adjusted. If you think that cos squared theta is 1/2 1 plus cosine 2 theta, if you're willing to accept that that is true, and it is, think of theta as being a placeholder. So it could be cos squared y, cos squared x, right? And it wouldn't really change anything. But more than that, I'm now going to use it to get cos squared to 2 theta. So using cos squared theta equals this, I'm now going to find out what cos squared 2 theta is. It's going to be 1/2 1 plus the cosine of how many thetas? If cos squared theta gets you this, what will cos squared 2 theta get you?
4 theta?
Yeah. That's one I'm pretty sure you've never seen, but it still exists. So we can now do, went grey, the integral of 1, take away that fella, plus this. And I think I'm just going to multiply this guy out to save a line of work. And doing some tidying up while I'm at it. 3/2, take away this guy, add this guy. So everything that we've essentially done from here all the way down to here was all working with trig identities in algebra. I haven't done any U subs or any algebra. I'm ready to go now. I don't know, that 3/4 is going to be awkward no matter what I do with it, so I'm leaving it where it is. That guy is him. If you do the shortcut on a cosine, you get a sine of 2 theta, but then you divide by 2. And so that's just going to be that fella. And a cosine will get me a sine of 4 theta. But then I'll divide by 4, which makes that guy an 8th, plus a c. And could you, I know, multiply that all out to just get rid of the brackets? That is every combination of, almost every combination of sines and cosines, and sines on their own when they're odd, and sines on their own when they're even. Are we good? Or are we at least okay? Are we okay? Okay. So I'm trying to think of one permutation I haven't done, and I've just found one, so here it goes. And this is a version of question 8. What do you do when sines and cosines are both even? That's the problem.
In this instance, could you, it would be really ugly to like swap the signs for 1 minus cosine and like multiply it out, right? That would just make it worse.
You would think it would make it worse, but actually it's what you have to do. So we'll just hold that thought and let's see where this leads. Not quite what you said, but the idea was there. Now you might say, well, what good is that going to be? Well, I am going to, well, let's pull that 8 out. That's not that important. And let's combine them to be this fella. And then we'll have this fella. There we go. And you might be thinking, wonder where he's going with this. This doesn't seem to be, working well. But let's just hold your thought process. I am going to use an identity, yet another one. And the identity I'm going to use is that sine theta cosine theta is 1/2 the sine of 2 theta. I've just rearranged the sine of 2 theta as 2 sine theta cosine theta. Now that makes this fella 1/2 the sine of 2 theta squared. Cos squared theta could be written as 1 minus sine squared, but it doesn't help. But it can be written as 1/2 1 plus the cosine of 2 theta d theta. So what I have done here, and thankfully I think there's only one, if at most 2 of these, is I've turned this entire horrible mess into a worse horrible mess, but at least the horrible messes have sines of 2 thetas and cosines of 2 thetas in them. And that's going to be important later on. So I'm squaring this out to get that guy. And I'll leave this guy for the time being alone. I'm going to pull that out and that out, which is an 1/8, which cancels with that, which is a bit unusual, but that's fine. And when I'm finished, we got that guy. Are we comfortable with this process so far? Because there is a lot of trig stuff floating around here. Are we good to this line? Okay, now. Going to distribute the sine squared 2 theta. I'm going to split this question into 2 separate integrals. This is our last question, obviously. Now, each one of these, we're going to deal with in a different way. Remember I did a cos squared 2 theta and I wrote it as this. I'm going to use the same strategy on the sine squared 2 theta. it can be written as 1/2, 1 minus the cosine of 4 theta. And then I can do 1/2, take away 1/2, the cosine of 4 theta, d theta. And would you agree that I can now integrate that using the shortcut method? Since I'm running short of time, I'll just have to talk you through this one. What technique will I use to integrate this fella? Do you see any technique for integrating this fella?
Would that be doing the sine squared cosine squared one, but with 2 theta instead of theta? No, that's the even odd. You can do u sub on sine squared.
You nailed it. Oh, not sine squared, but on the sine
Just
part,
sine, yeah.
right? And can you trust me on this one that you end up with that guy? And you end up with that guy. And off you go. I think in fact, I'm sure there's only 2 sections for this week. Can you understand why we need a whole week to just do 2 sections if they're going to be as long as this one is? And they are. We're only about 1/3 of the way through all the things that can happen in this section. So you are going to be really good at trig by the time this week finishes. Okay, last name and bye-bye. And I'll hang about for a few moments. If you have any questions.
Just thanks for the homework over the weekend.
Oh, you're welcome, Dave. Did it help?
Yep.
I'm saying, I hope it helped.
Yep.
Good.